Welcome back to another episode of Dave Does Math from Home. This one is about quadratic equations, section 1.5. If you're coming here straight from watching section 1.2a, where we talk about linear equations, I have some good news and bad news about the similarity of this section to that section. There are some important similarities. We are still dealing with equations, which is nice. When we have an equation, we can do literally anything we want to both sides of the equation, as long as we do the same thing to each side. So that gives us a lot of freedom to do anything, which is nice. The other similarity is that we are still dealing with polynomials. In linear equations, we had first-degree polynomials. Here we have second-degree polynomials. So they're still polynomials, which is nice. Polynomials are like the base level functions, expressions. They have they're very smooth, they're very well behaved, they're no weird stuff. So that's nice, that's good. Unfortunately, the similarities end there. And here's why. When you have a linear equation, there's only two kinds of terms in a linear equation. There's terms that have x and terms that don't have x. Those are the only two options in a linear equation. Something either has an x or it doesn't. And when those are the only options, it's very easy to separate them because we have an equal sign, and the equal sign has a left side and a right side. There's two sides of an equal sign, and there's two kinds of terms in linear expression, so we can split them by the equal sign. X is over here, constants over there. That makes solving those really nice and straightforward. You get your x as equals this, and then you're done. We will not be able to do that with quadratic equations. Quadratic equations have three kinds of terms. There are terms with x's, there are terms with no x's, and there are terms with x squared. And the x squared terms and the x terms are not like terms, and they cannot be combined. Those are different kinds of terms. So we have three kinds of terms, and we still only have two sides of our equal sign. So the standard technique of get x's over here and non-x's over there, it won't work. That's just not going to do anything for us, unfortunately. So we're going to have to get creative. And here's about what I mean. Let me reiterate some of these ideas with an example on the board. A fairly standard-looking quadratic equation we might see is x squared equals 6x minus 8. This might be a quadratic equation. Well, it is a quadratic equation. Has an equal sign, is a quadratic polynomial, quadratic equation. A common mistake I see students making is to try and move the 6x over here. So now you have your x squared minus 6x equals negative 8. The mistake usually turns into students will try to smash these things together into one term. And then they have their one term with x's and then an 8 over here, and they'll try to find how that works with a solution. But these cannot be smashed together. They are not like terms. Having them together over here doesn't really help us at all, unless the 8 is also over here. So I'm going to move the 8 this way so that I have x squared minus 6x plus 8 equals 0. And now this isn't about getting everything over here. This is about having one side equal 0. When you have an equation that equals 0, that gives you a lot of information about the equation. That helps us solve the equation in big ways because 0 is a very special number. This technique we're about to use to solve this only works when one side of the equation is 0. And that's because if you factor this, now you have two pieces, two factors that are being multiplied together. Here's piece A, here's piece B. These are two things that are being multiplied together to get 0. And the very special thing about two numbers that multiply to give you 0 is one of them must be 0. The only possible way you can multiply two numbers together and get 0 is if one of them is 0. So we know when we have these two things multiply to give us 0, we know that either x minus 2 is 0 or x minus 4 is 0. And if this is true, that means that x must be 2, and if this is true, that means x must be 4, and these are our two solutions to this quadratic equation. This is called the zero product property. When you get something set equal to 0 and then you factor it, and you know that one of those factors must be 0, because that's the only way to get 0 as a product. This idea is very important. It's going to come up over and over and over again throughout math. It'll show up in pre-calculus, calculus, calc 2, calc 3. It kind of never stops being important. Like, things multiplying to 0 is just always a big deal, because it always gives you a lot of information about those things. One of them must be 0, and that gives you your solutions. This doesn't work if you set something equal to -8 and then try to factor this. Oh, that won't help you. There's lots and lots and lots of things that multiply to -8, like -8 and 1, or -16 and 1/2, or -32 and 1/4, or -64 and 1/8. There's infinitely many different things that multiply to -8, or any other number. But if something is 0, things being 0 gives you really firm, concrete, usable information about that. So that's the goal. I'm going to do one more like this, and then we'll talk about some other techniques for solving these things. So let's look at 5 minus 5x equals 3x plus 4 times x minus 1. Sometimes you're going to have to do some work on these before you can set something equal to 0. So some of these involve more effort than others. This part can stay for now, 5 minus 5x, that's fine. We have to FOIL this out, so that's going to give us 3x squared. 4x minus 3x will be plus x, and then minus 4 on the back end. So we have 3x squared plus x minus 4. Now we can move these things over so that we can get 0 on this side. So I need to add 5x to both sides, and I need to subtract 5 from both sides. So now I get 0 equals 3x squared plus 6x minus 9. This is nice. This is very workable. We had to put a little effort into foiling this so we could get here, but now we're in a good place. I'm going to pull a 3 out so that I have x squared plus 2x minus 3. And now this thing, I think, factors very nicely. We can make that be x plus 3 and x minus 1. That'll give us the -3 on the back end and a +2 when we add them. So this 3, you could leave it here if you wanted. If you want to divide everything by 3, like divide both sides of the equation by 3, you could, and it'll cancel out here and it won't do anything there. 0 over 3 is just still 0. So you could get rid of it. You could leave it there and just know that 3, this piece doesn't have an x in it, so it's not going to contribute a solution. These pieces have x in them, so they will contribute solutions. Solutions will be x equals -3 and x equals 1, because those are the x values that will make this 0 and then it's true. 1 will make this 0 and then it's true. So these are your solutions. And we could check them here if we wanted to. 5, let's check 1. X equals 1 seems like the easiest. to check first. So if x is 1, this would be 5 minus 5 is 0. 7 times 0 is also 0. So one works. That one's nice. Let's try negative 3. At negative 3, this would be 5 plus 15 is 20 equals 3 times negative 3 is negative 9 plus 4 is negative 5 times negative 4, also 20. Yeah. So both of these solutions work. We can check them. Everything works out real nice. So this is what I consider to be the basic technique. This is sort of always my fallback plan. Whenever I see a quadratic equation to solve, my #1 driving instinct is set one side equal to 0, factor the other side. There's your solutions. There's a couple other techniques we're going to talk about here, but this is the baseline. Make it equal 0, factor. Sometimes we'll get quadratic equations that look like this. Sorry, not 4, 2. Sometimes you get quadratic equations like this. And before I do the other technique here, I want to just do the basic technique so that we can see what that looks like. Squaring this isn't hard. That would be x squared plus 2x plus 1 minus 2 equals 2. So I can move this 2 over here, subtract 2 from both sides, and combine everything. And you get x squared plus 2x. 1 minus 4 should be negative 3. What's that? Whoops. I didn't realize that this was going to be the exact same polynomial equals 0. That's fine. We know that this factors into x plus 3 and x minus 1 equals 0. So yeah, x equals negative 3 and 1. So the basic technique of set it equal to 0 and factor still works. I probably should have, I just did this one like, I didn't actually do it in my notes, so it's weird that it's the exact same polynomial halfway through, but that's fine. Set it to 0 and factor, still a good plan, always a good plan. For things that are set up like this, there is another plan that is available to us. I said at the start of this video that the thing where we get all of our x's on one side and all of your numbers on the other side doesn't work because there's 3 kinds of terms. Right now, this only has 2 kinds of terms as written. If you wanted to add 2 to both sides of this, you would get x plus 1 squared equals 4. And from here, there's only one x. You could isolate this x by taking a square root. So I think the book calls this some kind of like the square root technique or something. Honestly, I don't like the square root technique because most students will take the square root of both sides and they'll come up with this. And they'll be done, and they will be wrong. The problem with the square root technique is that it's very easy to forget that when you square root things, you should expect 2 possible outcomes. So this is going to turn into a 2, or maybe it's going to turn into a negative 2. If you go the factoring route, it's very hard to miss a solution. like you'll get these two factors, and they will be very clear and present what the factors are, and you'll have your two pieces. Here, it's very easy to miss a solution, and then that just always feels bad. So technically, from this point, this gives you like two different equations. And you have to solve these two equations separately. So you have to add 1 to both sides of this, and that gives you x equals 3. Did I do this one wrong? No, God, you have to subtract 1. Blah. Losing my mind. That gives you x equals 1, which we have over here. Here you have to subtract 1 from both sides. That gives you x equals -3, which we have here. So the two solutions you get are the same two solutions you get from this technique. You just have to remember that if you're square rooting something, you get two options. So the fact that students frequently make mistakes with this technique, combined with the fact that this technique only works on things that are set up a certain way, honestly makes me just not like it much at all. But I wanted to show it to you so you can have it available to you if you want to use it for certain problems. You always have the option. If you never ever use this technique ever for anything and just always do things with the factoring technique, great. I would actually really appreciate that. But here it is if you want it. We're at 16 minutes, so we're going to cut this video. There's more I need to talk about. There's a third thing we need to talk about. Honestly, it's a little boring, but we should mention it. But I'll put that in the next video. So stay tuned for part 2.